Question number 5 is also differentiation. In A, we have to prove that d by dx of 2 to the power x is 2 to the power x ln 2. For that, first of all, what we have to write is we have to express 2 to the power x in terms of the exponential function. So we can write this as d by dx of 2 to the power x can be written as e to the power ln 2 to the power x. So this is the first step where we can write it as e to the power ln anything is that thing. So e to the power ln x is x, e to the power ln 4 is 4, e to the power ln 5 is 5, e to the power ln a is just a. So 2 to the power x has first to be written as e to the power ln twice x. Now we have to simplify this, and we can take the x forward and we can write e to the power x ln 2. Now notice here x ln 2 is a constant, so this is basically e to the power some constant multiplied by x, just like this. If we have d by dx of e to the power some constant of x, we write it as e to the power ax into d by dx of ax, which turns out to be a. So that is the general rule. So what we can do over here, we can now think of this as e to the power x ln 2 is going to be e to the power x constant, ln 2 is the constant coefficient, into d by dx of x ln 2, just like ax. The constant a is ln 2. So it turns out to be, we can write e to the power x ln 2 as e to the power x ln 2, and d by dx of x of any constant is just that constant, so it is going to be ln 2. But the format has not been shown, so we have to do one more step, because we have to show that this is 2 to the power x ln 2. We got the ln 2 part. So what we can write now is, we can write e to the power x ln 2 as, we can take this x back, we can write e to the power ln 2 to the power x, and here we have ln 2. So we know e to the power ln 2 to the power x is just 2 to the power x, and we can write 2 to the power x ln 2. Question number B deals with implicit differentiation, where x and y, they are mixed together and we have to differentiate like that. So in question number B, so let's start by differentiating both sides. On the one side we have d by dx of twice x plus 3y squared plus 3x squared y plus 12, and on the other side we have to differentiate d by dx of 4 multiplied by 2 to the power x. We just differentiated 2 to the power x, it is going to be 2 to the power x ln 2. So if we differentiate on the left hand side, it turns out to be twice x is going to be 2, differentiation of twice x is 2, plus now 3y squared, this is implicit differentiation, and the rule goes like that. If you differentiate y to the power n, it is going to be n y to the power n minus 1, and then we have to write a dy by dx. So that's the rule for differentiating this term. So we can write 3 is the constant, so y squared is going to be 2y, and then we're going to write dy by dx. Now this one is actually the product rule, 3x squared y, this is a product rule. So if we differentiate this, this is going to be u is 3x squared, v is y, so this is going to be u d by dx of v, which is y, plus v d by dx of u, which is 3x squared. Now the constant 12 is going to be 0, so there's not going to be anything over here, equals to, now we have 4 is the constant. Now d by dx of 2 to the power x, we just did this, d by dx of 2 to the power x is 2 to the power x ln 2, so that's it. Now let's simplify this. This is going to be 2 plus 6y dy by dx plus 3x squared, d by dx of y is dy by dx, plus y, 3x squared is 6x, equals to, this is going to be, we can write 4 ln 2, and this is multiplied by 2 to the power x. Now from here we have to find dy by dx. So what we can do is bring dy by dx on one side. So dy by dx is going to be 6y plus 3x squared if we take it common, and let's send everything to the other side. It is going to be 4 ln 2 to the power x minus 6xy, I'm sending this to the other side, minus, and this 2 to the other side, minus 2. Therefore dy by dx is going to be 4 ln 2 to the power x minus 6xy minus 2 divided by 6y plus 3x squared. So now we have an expression for dy by dx. So what we have to do is find the equation of the tangent. Now for the equation of a tangent, we need to know the gradient of the curve. We know the gradient of the curve and the equation of the tangent, and the gradient of the tangent is the same. So we did not find the gradient yet. We just found an expression for the gradient. So for the gradient, we need the point. So at the point P, x is 2 and y is 0. So we can find the gradient dy by dx 4 ln 2. So x is 2, so we can write 2 to the power x means 2 to the power 2 minus 6 xy. X is 2, y is 0 minus 2 divided by, we have 6, y is 0, y coordinate is 0 plus 3x squared is 3 2 squared. So now we can calculate this. Then we have this term becomes 0, so this is minus 2 divided by 6 0 is 0 plus 4 3 is 12. So this is the gradient. We can simplify this. 16 by 12 is going to be 4 by 3 ln 2 minus 2 by 12 is going to be 1 by 6. So the gradient of the tangent is also going to be the same as the gradient of the curve at that particular point. So gradient of tangent equals to 4 by 3 ln 2 minus 1 by 6. So the equation of the tangent is going to be y minus y1. Since the point P is 2 0, it's going to be y minus 0 equals to m is going to be, the gradient is going to be 4 by 3 divided by ln 2 minus 1 by 6. X minus x1 is going to be 2. Since they did not ask for any particular format of the equation of the tangent, it doesn't really matter whether we simplify this or not.